Okay, this is 2.3. We're going to be talking about line graphs, and as the name suggests, they're basically graphs that have a line on them, like this. And it's just a matter of knowing how to interpret them, how to interpret the information, learning a few key terms, and then you can draw them. Okay, so let's try these. Circle the sentence that describes a histogram. Well, that's from 2.2, the previous one. A histogram, it displays data in ordered columns. I would say yes. It displays, or it has information is represented in intervals. Yes, that was the key thing. Intervals is the key function of a histogram. The vertical axis, this axis here going up and down, shows the frequency for each interval. Yes. And the bars have the same width and are connected. Yes. So all four of those points are true for a histogram. But now we're going to be talking about a line graph. So let's go to an example. Camden and Maria drove a delivery truck from Brandon to Thompson, sounds like it's in Manitoba, in a day. They created a graph from their notes about the trip, described their trip. Okay, so here's the total distance that they traveled in kilometers, and here's the time of day. Okay, so describe the trend. Well, the trend. Let's look at the graph. The trend basically indicates what is happening with this line graph. Well, it looks like it's going up and to the right. Okay? As time increases, so as we go from 6:30 starting point right here to later on in the day, it looks like the intervals are by an hour, each one of those. As the day goes on, as time increases, we could say that the distance traveled, the bar graph is, or line graph is going up, the distance is getting greater. So the distance traveled, as time increases, distance traveled either increases, or you can see there's certain sections on here, and here, where it stays the same, or the graph stays the same. Okay, which means that they did not increase their distance when they were traveling. Does the graph show they stopped at 9:30 a.m.? Explain. So let's go to 9:30 a.m. Well, there's 6:30, there's 7:30, there's 8:30, there's 9:30. So let's go up to 9:30, and then from 9:30 to 10:30, you can see that they traveled no distance. The distance stayed the same. So that means they probably stopped. Maybe stopped for gas, or stopped for lunch, or stopped for breakfast. Okay, for that 1 hour. Okay, so does the graph show they stopped at 9:30? The answer is yes. Explain. Well, because the line is horizontal. Has not increased, indicating that they traveled more kilometers. Okay, how far had they driven before 9:30 a.m.? So before 9:30 a.m. So we know that 9:30 a.m. is right here. They started at 0, their starting point, and at 9:30 they went, well, this looks like it goes up by 100, 200, 300, there's 400, so there's 300. Looks like it's just below 300 kilometers. So about 300 kilometers. How long did the trip take? Well, they started at 6:30. Well, is that the whole trip there? How long did the trip take? Well, the trip started at 6:30 in the morning, and it ended here. Okay, so we go down on the graph, and it looks like it ended at 9:30 p.m. So from 6:30 in the morning to 9:30 at night is 18 hours. It's about 18 hours. Okay, from 6:30 in the morning all the way up to 9:30, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, it looks like 15 hours. 9 plus, yeah, it's 15 hours, not 18 hours. I don't know what I was thinking. It's a 15-hour trip, okay? Okay, so you just count the intervals there. All right, let's look at another one. Example number 1 here. Latest truck can hold up to 1,000 pounds. She used an online converter to get these equivalent masses. How many kilograms of construction material can she deliver in her truck? So she's got these conversions right here. She can hold up to 1,000 pounds, but she wants to know what that is in kilograms. So label the scale for mass in kilograms and scale for mass in pounds. Plot the points in the latest chart. Complete the line graph. So let's just go and complete the line graph right here. So we got the mass. Well, our largest mass goes up to, in kilograms, goes up to 50. So we could say this is probably 10, 20, 30, 40, 50, and then our largest one for pounds goes up to a little past 110. We always start at 0. So we can probably say this is probably 20, 40, 60, 80, there's 100, and up there is 110 approximately. Okay, so let's complete it from the chart here. So 10 kilograms is 22 pounds. So we'll go to 10 kilograms is about 22 pounds. Let's put a little dot right there. 22 kilograms is a little over 44. So 20, there's 50, it's about there. 30 kilograms is about 66. So there's 60. There's 70, 66 is about there. 40 kilograms is about 88, so there's 40, we'll go to 88. There's 90, 88 is about right there. And 50 kilograms is about 110, so it's about right there. So we can connect these with a straight line all the way through, like that. Okay, so what trend does the graph show? As the mass in kilograms increases, as it goes from 0 towards 50, the mass in pounds also increases. Okay, you can see it's getting larger too. The points lie in a line going up and to the right in that direction right there. So we have to understand a couple of terms here. The word interpolate. To interpolate data means to estimate between known points. So if I've got a point here and a point there, I want to estimate in between. That's what interpolate means. So it says interpolate to convert these masses. So using this chart here, using this line graph, sorry, not the chart, a 7 kilogram box of nails is about, so 7 kilograms. So I'll go find 7. Well, there's 5. 7's about maybe close to halfway here. I go up here till I hit the line, and then I go across this way, and I can say that there's 7 kilograms is probably close to around maybe 15 pounds. A 54-pound bag of cement, so I want to go to, there's 50, 54 is about right here. So if I go across to the line, interpolate, and I bring it down here, 54-pound bag of cement is roughly around 25 kilograms. Okay, it's not exact, but it's close. Okay, so that's what it means to interpolate. It means to read data between the points on a line. What is the total mass in kilograms that Layla truck can carry? Well, on the graph, 100 pounds is about, let's see, 100 pounds is about, looks to be a little bit more than 45, maybe about 46 kilograms, maybe 46, 47. So if you multiply 100 by 10, you know that 1,000 pounds is about 460 kilograms. Okay, approximately. It's not. You can use the conversion chart in your calculator to get an exact number, but if you were just going to use this graph here, that's how you could interpolate. Now we're going to do another graph, and we're going to learn another term. Shauna created this graph about fuel economy of her hybrid vehicle. How far can she drive on a full tank of gas? Okay, so what we're going to do is we are going to learn a new word of vocabulary. It's called to extrapolate. It's to estimate beyond known points. So past points, not between points. We want to estimate between points. That's called interpolating. We want to go past it. So how much gas did Shauna start with? Well, she started with, looks to be, there's 60, there's 70, maybe about 62 liters, give or take. What trend does the graph show? As the distance traveled increases, as this gets larger, what's happening to the line graph? The volume of gas decreases. The points lie in a straight line. Going down and to the right. Going down and to the right. Okay, so we want to extrapolate by extending the graph to show when the tank is empty. So how do we do that? Well, you take your ruler, connect it to this point right here, get your ruler on that line, and then you want to do is you want to draw a straight line as straight as you can down to where it touches the horizontal axis. Okay? Somewhere around there. So Shauna does not buy any gas. Then she drives about, look at this number here, it touches about this point here, and it's around 1,200. Around 1,200 kilometers before the tank is empty. Okay? So, you've learned a couple of vocabulary terms here. To interpolate, which means to read between points on a line. To extrapolate means to extend beyond the points on a line. Okay? So a line graph is very simple. It's just a graph that is a line, and the line can be different shapes. It can go up to the right, down to the right. Okay, it can go horizontal, it can go vertical. Okay, it's just a matter of being able to interpret it. Okay, so go ahead and try the practice on the next couple of pages and see if you can interpret some line graphs and see if you can draw some line graphs from the data given. Okay?